We are looking for a presenter for one of the papers. Not here? And also, I'm looking for the presenter of a paper, time domain agnostic contactless fingerprinting. Are the authors here? No? Okay, so let us start. I think our first presenter is a paper entitled Enhanced Real-Time Emotional Amplification in Gaming via Physiological Vibrating Feedback by Yuki Kasuge and Shogi Okamoto. And I believe Ms. Yuki is presenting, correct? Would you please come here? All right. And so you can use your own laptop, and I'll try to time you. When it comes like 15 minutes, I'm going to wave my hand, and you have to stop. All right? So, all yours.
Can I?
Yeah, come here.
Okay. Okay. Good morning, everyone, and thank you for coming to hear my presentation. And I'm Yuki Kosuge from Tokyo Metropolitan University. Okay, let's start my presentation. Okay. I'd like to give a presentation entitled Real-Time Emotional Amplification in Gaming via Physiological Vibratory Feedback. Recently, there has been increasing interest in methods that use vibratory stimuli to enhance the experience of audiovisual content. This approach stimulates interoception by applying vibration in sync with the timing of emotional arousal triggered by the content. By influencing the emotional arousal system, vibratory stimuli can enhance arousal-related emotions. Emotion amplification system require the presentation of vibratory stimuli simultaneously with emotional arousal, emotional scenes. For example, to amplify fear in horror movie, vibrations are presented to match the scene of the monster jumping out, called jump scare scene. For this reason, the previous 20 years of emotion amplification research have used the music and video content that can be used to pre-identify emotional scenes. In other words, previous methods cannot be applied to interactive content such as games, where the timing of the emotional arousal is unknown. To enhance emotion in such content, we focused on the skin conductance response to determine the timing of emotional arousal. SCR is known as physiological signal of arousal because it indicates the electrical activity of the skin due to swelling associated with arousal. SCR is a relatively fast response signal that begins to rise within 1 to 3 seconds after stimulate presentation. Therefore, it is possible to discuss the evoking of momentary emotions. Usually, SCR are measured from fingers, and the same effect can be expected from the inner foot and the shoulder. In this study, due to the convenience of the experimental system, we use SCR from participants' foot. This study aims to amplify arousing emotions by real-time vibration feedback during interactive content experiences. The challenging point is the use of SCR measurement to determine the timing of real-time vibration output. This allows us to apply enhanced technique using vibration to content with indefinite scenarios. In the experiment, we use a combat and treasure hunting stage as emotion interactive content. The video shows actual game screen. The game was designed to randomize the appearance of enemy and rewards. So the timing and the type of emotional experience varied from each trial. The game evokes a variety of emotion through the combat and discovery of gems, including anger, frustration, joy, and relief. Vibration stimuli are presented to the diaphragm region and its back with two voice coil motors attached to a vest, like this. And these are triggered when SCR rises above the threshold compared to the mean SCR value from the previous 3 seconds. Threshold values were adjusted for each participant to control the delay between the game screen and vibration output. Then once the output is finished, the vibration presentation is stopped for minimum 2 seconds. After this interval, the triggering judgment restarts with this process, and it's repeated until the end of the game. To investigate the emotions through the game experience, an overall evaluation was conducted. Participants rated the intensity of these 10 emotions during gameplay on 9-point scale. They responded with value of 0 if they were not evoked once during the experience. Then they rate on a scale of 1 to 8 if evoked for even a moment with higher number indicating stronger. Before experiment, participants applied electrodes to their left inner foot for SCR measurement and wore a vibration vest. Once SCR reached a steady state, they played game for 150 seconds while SCR data were recorded. After gameplay, participants provided an overall evaluation. Each participant completed this process twice with and without vibration in random order. The participants were 10 college students, and a one sample t-test was performed on the scores of evaluation and SCR feature of game experience. For subjective evaluation, the mean scores of each attribute were compared between condition with and without vibration, and the Bonferroni collection factor of 10 was applied. SCR activity was investigated as an objective evaluation, and this figure shows the SCR waveform during a 150-second game experience. Then the local maximum value were taken as the peak, and its peak value, the peak amplitude, the standard deviation of SCR value and the number of peak per execution were compared between two conditions. Overall rating results are on this page. This graph shows the mean and standard error of the participants' overall ratings. And angry and excited score increased significantly in the vibration condition. And some emotions, especially frustrated and disappointed, also tended to increase with vibration. Next, here are test results for SCR features. While there are no significant changes in the peak value and amplitude, the variability of SCR and the number of peaks was significantly increased by the vibratory stimuli. These results suggest that vibratory stimuli led to an increase in SCR activity and heightened the physiological arousal. In terms of subjective evaluation, the intensity of arousing emotions such as anger and excitement were enhanced by the vibratory stimuli. In addition, although tense is the most arousing emotion among the attributes we used, but no effect of vibration was observed. Because tension scores were already high, even if the no vibration condition, suggesting that there was little room for further amplification. So, not all arousing emotions were uniformly enhanced by this method. Okay, on the other hand, the non-arousal emotions were not affected by vibration. It is understood that we applied high-frequency vibratory stimuli, and those were used to amplify arousal-type emotions. Therefore, there was no effect on low arousal-type emotions. And finally, this is conclusion. This study proved the concept of the new method of emotional enhancement interactive content using vibratory stimuli to the upper body. A real-time vibration feedback system was made based on SCR elevation. Vibratory stimuli amplified SCR activity and arousing emotions such as excitement and anger. This system has potential application in entertainment technology that enrich the user experiment. That's all. Thank you for listening.
Thank you very much. Now we have time for questions and answers, and I'm going to ask the judges if they have any questions.
I got first one for you. The equipment you put it on the chest, did you make that yourself or is a commercial product?
Okay.
That one, yeah.
In our lab, we use this equipment for before studies, previous studies, so I didn't make it, but the position of vibrating, position to stimulate is decided by my...
Look, I know that you didn't make it. Do you research group make that equipment yourself or you purchase from outside?
Oh, no, it is made by...
Made by your research group?
My labs.
So when you take this equipment, you already be ready, it is ready to be working in your research group. All your work is taking the signal and then do the amplification. Am I correct?
So you mean this equipment is already...
It's already there?
Ready.
Okay. The other one, when you take the sample, you mentioned how many samples you took.
Samples, okay.
You took the university students, I forgot how many you take that to do that kind of plotting. Only 10 students?
Only 10 students, and each student completed once.
So do you do the verifications after the 10 students? Do you check that one, whether that is correct or not? verifications. Once you take that students, you plot that table, right, in the next page.
The table, okay?
Yeah, that's only the 10 student distributions, right?
Yes.
Okay, and you did not take any kind of a new student to take whatever that compare with this result to verify that whether this table is correct or not.
Why that valid? Well,
Well, anyway, I think you didn't make it. You only make that students, 10 students. Okay,
Yes.
that's my question. Thank you.
Thank you very much, Philip. Anybody else? Great, thank you.
Thank you for your presentation. I think the question is you claimed that you have your method is you got a advantage over existing method. So existing method is a predetermined timing, and yours is real time. So can you highlight the novelty and the advantage again of your method in real time?
excuse me,
So-
one
so-
more time, please.
Okay. Can you highlight the novelty of your method in real time, okay, compared to the existing method, predetermined timing?
What you mean?
Your method is real time, right?
Yes.
Okay. So advantage of your method, highlight, compared to existing methods.
Okay. In previous study, they used the contents that can be pre-identified as scenes. So it is need to prepare the stimulate to match the content. But in this method, you don't need to prepare the stimulation to match the content. So we can use this, apply to this method to the interactive content such as games and other content like SNS maybe, or conversation of human-to-human communication. So it's the merit of this method. Okay, thank you.
One last question, maybe from me. So I just want to know, you have the overall evaluation slide, right? And then you have excited and frustration increase with vibration. And no, there is another one which is the overall evaluation. So yeah, so angry and excited increase with vibration, then frustration and disappointment also increase. These are pretty negative. So what do you intend to do in terms of future research so that, you know, there are more positive vibes?
So you mean how to increase the positive emotions? Okay. Okay. In this study, we use the combat and treasure hunting method. But most times of the gameplay, participants feel excited or tense and angry. So in this content, the enhanced emotion was maybe almost negative emotions, but if you want to increase the positive emotion, it's related to content, and also we and you think about more suitable stimulation, like vibrate with rhythm, and another way, we need a think of more suitable stimulation. Okay.
So thank you very much. I do have one question. What kind of vibration did you use in order to do stimulus? I mean, can you give me some technical details about the vibration that you used?
This one?
Okay.
Then one more time to
No, it's okay. I just wanted to know what kind of vibrations that you use in terms of frequency, amplitude, right?
Okay. But the stimulation is not optimized, so
Yeah, that was my question. Can you optimize the stimulation in order to get better results during a game? Did you play with that? Did you try to optimize the stimulation?
So we will to
Not only in terms of time, but
10 of time.
that's okay. Thank you very much.
Thank you.
Thank you. Anybody else? Are there any questions from the audience? Yes? I think this microphone would also work, right?
Thank you very much. It is very interesting. So I want to know how to detect the timing to make a vibration. I think in my thought, when the zombie comes in a game, at the very timing, the controller may give vibration. So, yeah.
So controller. So we detected the timing of the vibrate to stimulate the vibration. So vibration is when the SCR is rising. Then most of situation, the rising starts from the simultaneously combat starting. So and when last fighting scenes, vibration is coming. So then the timing was controlled by threshold. The threshold was decided before the experiment, the test play for preparation of experiment, and then in the test play we measured the SCR of each participant, and then according to the test SCR measurement, we decided the threshold, and then the timing of vibration is decided to when the combat timing. Okay.
Okay, thank you very much.
Thank you.
Thank you very much. The time is up, so let's thank the speaker again for the presentation and answering the questions. Our next paper on the list is the paper entitled Recurrent Polynomial-Based FBLS for Adaptive Predictive PID Control of Nonlinear Discrete Time Systems, Comparative Study on Control Performance and Time Complexity. And the presenter is Ali Raspavan, and the paper is co-authored with Ching-Chi Tsai.
It's not working.
So, good morning, everyone. Good morning, respective professor, and good morning, ladies and gentlemen. My name is Ali Rospawan, under guidance of my respective supervisor, Professor Ching Chi Sai. We are from Department of Electrical Engineering, National Chongqing University, Taichung, Taiwan. Today, I would like to bring our work, which is almost 1 year ago, with the title Recurrent Polynomial-Based Fuzzy Broad Learning System for Adaptive Predictive PID Control of Nonlinear Discrete Time Systems, where we will have a kind of comparative studies on control performance and also along with its time complexity. So for today's presentation, we will follow this outline, which consists of 5 subsection later. So to introduce our work, so this study background starting with the introduction of BLS and fuzzy broad learning before, which has gained a lot of attention from some researcher. And its application also has been successfully to some and various of application. But in terms of adaptive predictive PID control, an output recurrent FBLS, which is an improvement of ABLS itself has been proposed for the CISO system and also for the MIMO system. So what is the challenge of this research? We have two kind of challenges that we face for this research. The first one is the ABLS picture mappings, which is utilizing fuzzy k-means, is causing a kind of uncertainty on the fuzzy subsystem center itself. And also fuzzy k-means here is also limit the robustness of the original fuzzy broad learning systems. And motivated by those challenges, in this study we are going to introduce a kind of improvement which we have improved the learning capability of ABLS by replacing it with polynomial fuzzy broad learning system. And also after that we are going to utilize it to optimize the PID gain so it can have better set point tracking control, disturbance rejection, and also better in handling nonlinear systems. So there are 5 things that is a research objective for this research. The first one is we are going to develop a recurrent polynomial ABLS. The second one is we are going to enhance the nonlinearity capture by replacing the fuzzy k-mean inside the original ABLS with fuzzy c-means. And the third one is we are going to improve the interpretability deficiency in fuzzy k-means. Also, we are doing a kind of comprehensive simulation study. And the last one, we are going to have experimental validation to semiconductor heating oven. And for the contribution summary is written in these 3 things. We are going to the second section, which is the recurrent polynomial-based ABLS system as a system identification, where we will have 3 subsections later. So this is the total of overall of our proposed architecture design, where on the lower side here, we have a kind of fuzzy if-then rules, and then we will have a kind of fuzzy Gaussian membership function and its binding strength lambda here. And for the polynomial function, we have CISK here. And then for the fuzzy subsystem itself, we have Fs high here, and the output of these fuzzy systems obtained from these capital F equations. Furthermore, for the broad learning system, we have capital H here, and then the output of this overall system can be obtained from this capital Y hat equation here from the equation 13. So how do we update the wake parameter inside this recurrent polynomial ABLS? So firstly, we put all of the wake parameter inside the vector of pk in equation 14 here, and then we are utilizing a kind of error objective functions. And then utilize a gradient descent optimization. We got 6 equations here, which consists of all of the wake parameter for this ABLS, which has been written in this equation 14 here. And then we got theorem 1, which is for the system identifications. It is uniformly and asymptotically convergent if the learning rate for the system identification, which is eta, for each sampling instance is following this condition written in this equation 17. And to prove that, we are having 6 steps, and step number 1 until step number 4 are here. And step number 5 and step number 6 are written here. And finally, following the Lyapunov stability theory, the identifier convergence is guaranteed if the delta pk is lower than 0, then the proof is complete. And we are going to the third section, which is the proposed recurrent polynomial ABLS as an adaptive predictive PID control, where we will have 4 subsection 2 later. And this is the overall closed loop system configuration that we have been proposed here. The first one here, for the recurrent polynomial ABLS system itself here, we receive a kind of controller output and its delay, and also system output and its delay here. And as I mentioned before, we are going to utilize an error objective function to update the wake parameter inside this system identification. And then we have a predictive cost function k plus j here, which is a part of the Jacobian transformation. And then we use that to update the PID gain written in equation 19 here as KPK, KD, and then the change rate for this weight for this PID gain is obtained by this equation, which is delta Kp, delta Ki, and delta Kd. And then for the stability of this closed loop system, we are following 5 steps where the step 1 until step 4 are here. And then step number 5 is here. And then following this 5 step, we got theorem 2, where the system of this closed loop system is asymptotic stable if the control running rate where we write it as eta c on each iteration of sampling instant is following this equation. Furthermore, for the real-time control algorithm for this proposed system is written in this algorithm 1. And then we got theorem 3 for overall of this control system where the system is uniformly asymptotically stable under the condition if the theorem 1 before is satisfied and also theorem 2 is also satisfied. And then to prove that, we are following the similar proof procedure in my last paper in reference number 7 here, which is in IEEE Access before. And we are going to the section 4, which is a comparative simulation and also its application to semiconductor heating oven, and where we also will have a kind of time complexity comparative study here. So for the first example, we are going to do a simulation study following the nonlinear dynamic system writing in these equations with each parameter writing on the right-hand side here. And then figure 2 here shown the set point tracking comparison for this example 1, where we compare it with our last work, which is also our lab work. And then for the figure 3 here is the PID gain evolution from the sampling instance 0 until 1000 following the figure 2 here. And then from the table 1 here, we know that our proposed method in this example 1 is proof superior only in terms of IAE and ITAE, but it is inferior in terms of maximum error, RMSE and ISE. For the second example, we have the simulation study from following these very long equations, and each parameter is written here. And we got figure 4 for the set point tracking comparison and figure 5 for the PID gain evolutions. And then finally, from this table 2, we know that the proposed method for this example 2 is superior in terms of RMSE, IAE, and ITAE, and inferior in terms of maximum error and ISE. And for the last simulation example, which is also a simulation model for the semiconductor heating oven, the model is written here, and the set point is here, and the parameter for the simulation is also set to be similar with example 1 and example 2. And then we got figure 6 here, which is the set point tracking comparison, where as you can see here in the red line, we have that our proposed method has a faster rise time, a little bit faster rise time comparing with our last study. And from this table 3, we know that the proposed method in this example 3 proved superior in all terms of the performance indexes except for the maximum error. And note that all of the data written here is a kind of collective data. So we do a kind of 20 time of simulation, and then we make an average of it. And then this is for the experimental validation, which is the heating oven. This is the company use heating oven where we buy it before. And this is the controller itself where we use STM32 microcontroller board. And this is my computer for programming and monitoring in MATLAB. And then figure 8 here shown the set point tracking, the upper side, and the controller output comparative result on the lower side from the simulation study that I have done before, and compare it with the experimental result. And in figure 9 here, for the PID gain comparative result, which is also from the simulation and experiment. And lastly, figure 10 here for the learning rate comparison. And how about the time complexity studies? So for this system, comparing with our last study, which is ORF-BLS FPPID, which we have been published before, it is 20% higher if we are comparing with using MATLAB TIC and TOC function in MATLAB itself. And this is our computer specifications. And for the result, as you can see here, I put that for this system, it's run 2.4 seconds for every program, every samplings. But for the total sampling instant for this system is 6 seconds, so we still have a kind of 3.6 seconds spare for this program to run, so it's safe to run it on this microcontroller board. So to conclude this work, firstly, we have introduced the adaptive predictive PID control utilizing tools, recurrent polynomial FBLS, and we also propose it as system identifier to update the PID gain over time. Also, we have provided the tree theorem for the system stability and convergence, and we also have tested on the simulation study and on the experimental study on the semiconductor heating oven. And as you can see before, the system plan model significantly affect the control performance, where we have a kind of fluctuating result which is up and down in RMSE and IISE, and consistent outperformance or better performance in terms of IAE and ITAE, and also consistent inferior, which is always lower comparing with the last study in maximum error. And also 20% increase in computational time comparing with existing ORF-BLS, but still suitable for real-time application due to performance advantage. And lastly, for the future work, we are going to upgrade this method to be using output recurrent, which is actually has been done by me, but since this is the almost 1 year old paper, so I cannot show it here. And we also will testing it for the extrusion barrel later and also for the MIMO system. And this is the reference we have been used for this study. And lastly, thank you for your attention.
Thank you very much. Let's take the speaker. We do have time for Q&A. Yes, please.
I have a quick question for you. Okay, I think this is very good work. Can you just use a few words, just tell us what is the novelty you use in the recurrent polynomial network one compared to the original FBLS? What is the advantage you use in the recurrent polynomial?
Okay, thank you so much for the question. The novelty of this research, I can say that for the previous FBLS, as I mentioned before, the original FBLS using fuzzy k-means clustering and on the center of the fuzzy subsystem itself. And for this one, we are going to, we have been used fuzzy c-means. So based on some research study, fuzzy c-means has proved better comparing with fuzzy k-means. So this is one of kind of novelty for this fuzzy broad learning system. Thank you so much.
Okay, now comparing the timing, recurrent polynomial use much more time than the fuzzy c-means, right? You show up the computation comparison about almost 20%. Maybe that 20% is coming from the simulation, but in the computation of a polynomial time, maybe you spend more time than the fuzzy one, right? Am I correct?
Yes.
Now, from your result, I see a lot of improvement, which is very good. Now, compared to the offset of your improvement and the timing you spend, would that be a good design system that use this kind of improvement?
Thank you so much. For the time complexity, actually, this is, in my opinion, is still better compared with my new recent research, which is using a kind of model predictive control. That one has more and higher time complexity, and that one is also have been, I have submitted to another journal and still under review right now. And based on the experimental study on that paper that I have done before, is still fine. Okay. If I using this microcontroller board, which is STM32.
Okay, All
Thank
right,
you
thank
so
you.
much.
Yeah.
Thank you very much. Next. No questions? How about Professor Lee? No questions? I have a generic question. I see you are using MATLAB and toolboxes in MATLAB, right?
Yes, of
Have you
course.
considered moving into Python and tools that are actually readily available to the community without need for license?
Actually, if I can use Python, it will be better. But Python in terms of plotting is still like comparing with MATLAB. So until now, our lab still consisting us to use MATLAB. And also, I cannot say this actually, but my professor is not really good in Python, so it's pretty hard for me to communicate with him in
All right.
Python. So yeah,
Okay.
I'm using MATLAB
Thank
here.
you. Thank you very much. But there is a possibility to move, right? Because
Yes, of course.
most of the approaches to dealing with engineering problems these days are moving into Python and using tools that are readily available to the community, because not everybody can afford MATLAB license. So thank you very much. Any questions from the audience? No? Okay, all done. Thank you. Thank you.
Okay, thank you so much.
So our third presenter, actually fourth. Can I ask a question whether the author of the first paper on our list, Haitao Yuan, is in the audience? Okay, so let's do this and then after that. And how about the last paper for the Student Best Paper Awards? Eugene Liu, for the paper time domain agnostic contactless fingerprinting localization, no? All right, so we'll wait, maybe they show up. So please, go ahead.
Hello everyone, my presentation title is Muffin Multiplication Feature Extraction Network for Remote Session Science Classification. The report introduction, the method, experiment, and analysis and summary will be made in the following aspects. The science classification of high-resolution remote science images can be applied to urban planning, geological disaster monitoring, military security, land use, and other fields. The land cover for HRSRS has many details. Science classification involves utilizing detailed information to determine the semantic labels for science images. This paper conducts a thorough analysis of the predictive performance of the current models, revealing several pertinent issues. Okay. Number 1, number 2, and number 3 issues. Okay. This is the overall structure of our model. Image feature are extracted using a two-branch network. Then the MF model is utilized to extract high correlated features between the TNT branch and the swing branch. Afterward, the MFF model is applied to preserve the information maximally from the lower and middle layers. Finally, the joint loss is employed to balance the importance of different features, enhancing the model's convergence speed. Let's move on to the first model we proposed. The mutual attention fission model, we transformed the structure of features. Then we used the cross attention blocks to fuse the features. As shown in figure, we employed the cross attention fission module 3 times, generating shallow, middle, and deep level feature representations simultaneous. The formulas are as follows. Is a consistence of a convolution operation, an exhibit operation, an addition, and a multi-layer perceptron. Considering the complexity of science images and the high dependence of central science types on low and mid-level features, we designed an MFF model as shown in figure. Multiple level features are input into the MFF model, which consists of 2 addition blocks and 2 MLPS. Initially, shallow features are fused with mid-level features, followed by the fusion of the resulting features with deep level features. Shallow, middle level, and deep level features are denoted as A1, A2, and A3, respectively. The specific formulas are as follows. Finally, we used joint loss. The significant variation in scale of science images poses a major challenge for science classification. In response to the issue, we instructed a joint loss to facilitate the fusion of local and global features. Lambda 1, lambda 2, and lambda 3, and lambda 4 are hyperbolometries used to balance the width of different losses. We used the various evaluation metrics, including over accuracy and confusion metrics, to assess and compare our approach with existing methods. In this study, the effectiveness of the proposed methodology is validated using the public available data. This is UCM, AID, and NWPU. The table shows the comparison of our method with 7 other state of the other methods. The figure shows the confusion matrix on both data sets. We conducted ablation experiments on the AID 0.5 and NWPU 0.2 datasets to evaluate the effectiveness of the proposed method. The following 4 groups we constructed. This approach utilized the MAF model to integrate local and global features, significantly enhance the express power of features. Future of work can explore techniques such as knowledge distillation and multi-stage training to enhance model performance and training efficiency. Okay, thank you for listening.
Okay, thank you very much. Let's thank the speaker, and we do have time for questions and answers. So thank you.
Okay, okay.
Philip, you would like to start? No? How about anybody else? The question?
Thank you for your presentation. The question is, you define a couple of definitions in your global feature and local features. You separate this very clearly.
Okay, thank you for your question. Sorry, my English is not good. You can send me
Okay.
email.
No, it doesn't work with email. Can you show the slides? Can you tell him which slide
Okay.
to show?
Just briefly, the 3 level of features. Can you explain 3 level of features? 3 level, what they are?
论文的原作者不是我，我是来就是替朋友，他因为有些原因有事替他讲的。
So, sorry. I'm sorry, I didn't realize that you are not the author and you're actually presenting for someone else. So yes, we can send the questions through email, okay? Yeah, I understand you are not the author of the paper, you are presenting for someone else. Is that correct?
Sorry.
That's okay, all
Oh, okay.
fine. Anybody else has any questions? No, thank you very much.
Okay, thank you.
You're off the hook, thank you. Sorry about that. All right, so we do have the author of the paper that's first on my list. Is Haityo Yuan here? Could you please? Okay. So you're also a nominee for the Best Student Paper Award? All right, so please. And just to ask for again, is Haityo Yuan here? Oh, he's the one? Okay. Is Yijing Lu here? No? Okay, thank you. So I'm looking for Yijing Lu. Paper is time domain agnostic contactless fingerprinting. Not here? Okay, thank you.
Yes.
My laptop died, so I have no, can check it. No, but that's okay.
Okay, please. Oh, it's not there. Sit away. I'm very sorry for keeping you waiting. Shall I begin?
Yes, could you clarify for me? You are the second author, right? Yinjia Li.
I am the first author of the paper.
It says presenter, Yinjia Li.
Yes, the authors are below.
Oh, sorry, okay. So whatever we have in the, okay, please go.
Okay. Good morning, ladies and gentlemen. It is my great honor to be here to present my paper. The presentation title is Low Latency and Energy Efficient Task Scheduling for End-Edge Cloud Collaborative Computing. There are 5 parts in my slides. The first is introduction. End devices are the most common devices in our daily life, like the laptops, the cell phones, the printers, and so on. They often have customized applications, and they need fast execution, like the speech recognition, video rendering, and so on. However, they have limited resources such as the CPU memory, so they often faces the overloading problem, and thus the task processing time cannot be guaranteed. Therefore, it is impossible to totally run all tasks on them. Luckily, the mobile edge computing is therefore proposed. It consists of high-performance edge services and a power central cloud, where tasks can be offloaded to. In our problems, we care about 2 aspects. The first is task offloading, which refers to assigning tasks to be completed on certain computational nodes. The second aspect is resource allocation, which refers to the allocating limited resources to complete a certain task. So in our paper, we aim to jointly minimize the total time and energy consumption in an end-edge cloud collaborative computing network. There are 2 contributions. First, an optimization problem of an end-edge cloud collaborative computing network regarding task offloading and resource allocation is proposed. In this problem, we propose a method to calculate the total time and energy. Second, we consider the dependencies among the tasks. Thirdly, we try to minimize the total time and energy consumption to finish them. The second aspect, we propose a method, the improved NSGA2 with self-adaptive crossover and mutation. Okay, here comes the problem definition. Our end-edge cloud collaborative computing network consists of 3 parts: end devices, edge services, and central cloud. The task can be offloaded to the edge services and the central cloud. And every app can be divided into several tasks. Each end device submit an application, and they can be divided into several tasks. However, they have some dependencies where we can be shown in the DAG. So in the following orders, the first one is correct, but the second and third are wrong because they violate the dependency. Okay, here we are discussing some formula to calculate the time consumption. The first is the transmission time. If a task is offloaded to a remote edge server or the cloud, it has to transmit the data to compute. So this part of time is defined as the transmission time. It is equal to the amount of data divided by the bandwidth. The second part is the waiting time. Once the transmission is finished, it is ready to run, but it has to wait the other task to finish and so that they can release the computational resources. The third one is the execution time. It is calculated as the number of CPU cycles divided by the CPU frequency. So the total time of the tasks is calculated as T1 plus T2 plus T3. Here is the energy consumption. The first part of the energy is transmission energy. It equals to the transmission time times the transmission power. The second part is the execution energy. It is calculated as a coefficient of the chip plus the square of the frequency times the square of the CPU frequency times the number of CPU cycles. So the total energy is calculated as E1 plus E2. Okay, our goal is to jointly minimize the time and the energy. However, during the optimization, we have to obey some constraints. For example, the location constraint. A task can only be offloaded to an edge or the cloud. The CPU frequency constraint. The CPU's frequency cannot exceed the maximum values. The third is deadline constraint. An application must finish before its deadline. The fourth is power constraint. The CPU can only operate in a range of its power. The variables of our optimization is the offloading location and the CPU running frequency, which can be deemed as an integer and a real number respectively. Our problem is a NP hard one, so we try to use meta-unit-risk optimization algorithms. So here is the proposed algorithms. Our original version is the NSGA2, which is a bio-objective optimization algorithm. It consists of fast non-dominated sorting, elitism selection, crowding distance. On the basis of this, we made some improvements. The first improvement is the genetic encoding. We adopt a mixed genetic encoding strategy, where a gene is encoded as the offloading location plus the CPU frequency, and all genes are formed to be a chromosome. The second part is crossover and mutation. We adopt simulated binary crossover and random mutation. Most importantly, we devised self-adaptive crossover and mutation rates. The crossover rate decreases with iterations, and the mutation rate increases with iterations, which we believe is very helpful for the global exploration in the early stage and local exploitation in the later stage of the optimization. Okay, here comes the performance evaluation. Here we compare our algorithm with 3 benchmark algorithms. They are random offloading, the initial state before the optimization starts. The second is NSGA2, which is the original version of our algorithm, and NSGA3. We drew their Pareto fronts obtained by them. So you can see in the slides, the red dots represent our algorithm's solutions. It dominates other solutions, which can verify the effectiveness of our algorithm. In the optimization, we record their maximum, minimum, and average time and energy consumption of the population. You can see that the minimum and the average value decreases as the iteration count grows, indicate an overall improvement. However, the maximum value first decrease, then slightly increase, which indicates that the solutions are all Pareto optimal and the solutions are becoming more and more dispersed. Here comes the comparison experiment. We do some comparison experiments and we fix the number of edge services at 10 and increase the number of end devices from 2 to 20. So you can see as the number of end devices increases, both time and energy consumption ascend. And our algorithm harvests the smallest time and energy consumption in most cases. Okay, here we fix the number of end devices and increase the number of edge services from 2 to 20. And you can see as the number of end devices, so you can see as the number of edge services increases, both time and energy slightly descend. And our algorithm harvests the smallest time and energy. So we can say that our algorithm results in the best solution compared with other algorithms. Okay, here is the conclusion part. In this work, an N-edge cloud collaborative computing network, considering the dependencies of tasks and a calculation method of total time energy consumption is proposed. We also propose an algorithm called INSCM, which stands for Improved NSGA Tool with Self-Adaptive Crossover and Mutation. And our algorithm has better performance than other benchmark algorithms regarding time and energy consumption. In the future, we will consider a more complex UAV-assisted MEC network, and we will try our best to improve our algorithms. Thank you very much.
Thank you very much. Let's thank the speaker. Before we do Q&A, I need some justification and clarification. In the paper that was submitted, you are the second author, correct?
Yes, I'm the second author.
Okay. Are you also a student?
I'm a student, master's student.
And what was your contribution in the research and in the paper? Are you the major contributor?
Yes, the experiments are done by me, and the paper, the majority paper is written by me.
So why are you not the first author?
The first author is my teacher.
Oh, so the first author is your professor?
Yes, it's my professor. He guides me, he helps me, he encourages me.
Yeah, well, you probably realize that for the best student paper award, we expect that the student is the major author and the first author of the paper. I just want to clarify that. I'm sorry if we didn't make this very clear.
However, before this competition, we have changed the authors and order.
Well, that's why I'm asking a question, that you have changed the order of the authors before competition, but the submitted paper has different names of the authors, right? Oh. So usually, and anyhow, we as a committee will discuss this. I just want to clarify that the first author is a professor, and you are actually the second author of the paper. Because we have to go by the paper as submitted and accepted to the conference.
Okay.
So we have to go by what you submitted, and we have to go by the order of the authors that was accepted to be presented as a conference.
Okay.
And the rule for the best student paper award, I mean, it's posted on the web, and it's clearly stated that the main author and the first author has to be a student.
Okay.
Okay? I just want to clarify this so we do not have surprises later on. But as a committee, we will discuss the issue. So now I'm going to open the floor for questions, please.
Okay.
Yes, please, as always. Thank you.
Okay, thank you. About the work, what is the size of your experiment? You're talking about the edge and also the end device. How big the size, the size of your simulations?
Okay, I think our model is very complex. It tries to simulate the real-world scenarios. And the edge services, the number of edge services is approximately 10 or 20.
10 or 20.
Okay, and yes, then the number of end devices or the number of applications is 10 or 20 approximately.
Okay, the other one, okay, so this is the size. The other one, when you perform this kind of optimization, because you mentioned that it's an NP-hard problem, how much time, okay, let me phrase it, how much time you spend on calculation on this kind of the matching, the scheduling, compared to your entire simulation? What is the percentage of time? Can you do in the real time, or you have to do in the matching time? Every time you change the environment, you have to recalculate again. How do you do that? Two questions, yeah, put together.
Yes, we implemented using Python, and we set a hyperparameter, and we like the number of end devices or the number of edge devices. We modify the hyperparameters so the experiment can be redone.
So you have to recalculate again when you have a new environment.
Yes.
Okay. And then how much time it takes you to compare all the performance in the timing in your simulation? It takes, what is a milliseconds or microsecond in that range to calculate this kind?
Oh, it's a long time. I think
it's a long time.
Yes,
right?
it may be. It takes about 10 minutes to run the application.
That is a problem with this kind of genetic matching problem.
Yes, it's very complex.
Okay, thank you.
Thank you.
Anybody else? No? Please.
So in your paper, you mentioned that your method work for the real-time scenarios.
Yes.
And compared to this method. So can you confirm that? Do you think your work is the first of its kind for real-time scenarios?
I think our work is just a simulation.
Yeah, simulate. Okay.
Yes. And I think it will be of some values in real-life scenarios.
Okay. So just one more question, quickly, very briefly. So,
okay.
Can you tell briefly why your joint optimization works? Because this is a joint method.
Yes. Joint. What do you mean by?
Because you joint optimize, minimize that two tasks.
Yes, the time and the energy.
Yeah.
Yes.
Give insights briefly.
Some works tries to plus the energy and the time to be one value, and our work tries to minimize both the time and the energy simultaneously. I think this is the jointly optimized.
Okay, thank you very much.
Thank you.
Okay, thank you. All right, so thank you. I have a last call for the paper. One of the 5 nominees for the best student paper is the author of the paper here, Ieee Lu, or any of the co-authors, and the title of the paper is Time Domain Agnostic Contactless Fingerprinting Localization for LoRa Frequency Hopping. Last call. Okay, so I think we have to close the session because, do we have to leave the room? Yes, there's a keynote at 9:45. Okay, so I think, thank you very much for the nominees for the best paper. We couldn't fit you now. Please come in the afternoon. I know there was a confusion about the program, so I expect to see you at 3 o'clock, and I understand the room is next door. That's correct, yes. Madam Co-Chair? Huh? Is it 3 o'clock? 3 o'clock. So please check with us, we'll be here. So thanks again to the presenters and congratulations on being nominees for the Best Student Paper Award. And in terms of the committee, I think we have to convene now and make some discussion. So thank you very much. I will see you in the afternoon at 3 o'clock in the room next door with round tables.